Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. I know it's been a while since last update on the video. I'm sorry for the delay. I had several projects on my job, and one of them is extremely difficult. Luckily, I solved all the problems, and now I have more time to work on the geometry. And I also received a problem. I think it's an IMO problem. It was a very difficult one. We will get there, but let's just focus on catching up the geometry treasure progress first. Today we're going to talk about the 9-point circle supplementary. We had some videos on the 9-point circle in the past, and I think that's basic as a foundation of our discussion in this video and the following videos. So please review those videos on the 9-point circle basic first. The property 1. Actually, let me just quickly review the definition of the 9-point circle. So let's say we have triangle ABC. And we find the isocenter of the triangle ABC. So AD, BE, CF are altitudes. H is the isocenter. Then we know that D, E, F and the midpoint of each side, let's call it M, P, and midpoint of isocenter to vertices S, T, Q. These 9 points are cyclic, and the circle these 9 points on is called 9-point circle. Okay, that's a basic concept, just as a review. Now let's see the property 1. The 4 triangles of an isocentric system share a common 9-point circle. That's the first claim. And the second claim is all triangles inscribed in a given circle that share a common isocenter at a given point also share a common 9-point circle. Okay, for the first one, the 4 triangles of an isocentric system share a common 9-point circle. That basically saying the triangle ABC, triangle AHB, triangle BHC, and triangle CHA. These 4 triangles share a common 9-point circle, which is simply very simple to prove. We can think about the 9-point circle of the triangle ABC here. It's a circle FQENTDMSP, right? What about the 9-point circle of the triangle AHB? AHB. We already know that 9-point circle is a circumcircle of the midpoint triangle, right? So for the triangle AHB, we see the midpoint of AB side is P, and the midpoint of BH side is X, midpoint of AH side is Q. So we know that the 9-point circle of the triangle ABH is a circumcircle of the triangle PSQ, which means that's the same circle of the 9-point circle of triangle ABC, similar for triangle BHC and triangle CHA. Second claim, all triangles inscribed in a given circle that share a common orthocenter at a given point also share a common 9-point circle, which means that we already find the circle. Find a circle here, right? This is a constant circle. And we say that any triangles inscribed this circle, if all of these inscribed circles that, let's say we find a point here, we call it H, all of the inscribed circles that has H as its orthocenter, then all of these triangles share the same 9-point circle. It's very easy to prove. Why? Because we know that the center of 9-point circle is a midpoint of circumcenter and orthocenter. Right? We have a constant circle here. That means the circumcenter is constant. And we already fix another point as a orthocenter, which means we fix the circumcenter and orthocenter. Then we know that the center of the 9-point circle is a midpoint of these 2 points. That's the 9-point circle. That's the center of the 9-point circle. And we also know the radius of 9-point circle is half of the radius of circumcircle. And for a given circle, the radius of the circumcircle is fixed, which means that we have the fixed center, fixed radius, so we have the fixed 9-point circle for all the inscribed triangles. Okay, that's property 1. Property 2. The circumcenters of 4 triangles of an orthocentric system forms a new orthocentric system. The new system is symmetrical to old system on the center of 9-point circle V. So we have we need to consider about the circumcenters of 4 triangles of an orthocentric system, which means that we want to find the circumcenter of the triangle ABH, triangle BCH, and triangle ACH, right? Which can be found by, I find the perpendicular bisector of segment BC here, and we find the perpendicular bisector of the segment BH. Right. Then this point, let's call it X. That is a circumcenter of the triangle BHC. Similarly, if we find we can extend it here, right? And if we find the perpendicular bisector of segment AB, then we know that this point is because this point is a intersection point of the perpendicular bisector of segment BC and the perpendicular bisector of segment AB, which means that this point is a circumcenter of the triangle ABC. Also, this point is a circumcenter of the triangle ABH, right? Because it is an intersection point of the perpendicular bisector of segment BH and the perpendicular bisector of segment AB. Similarly, for here, we know that the perpendicular bisector of CH meets on this point, right? It's not that good draw. Anyway, And also we want to find here, let's call it Z, right? The point Z is a circumcenter of the triangle AHC because it's a intersection point of the perpendicular bisector of segment AC and the perpendicular bisector of segment CH, right? Now we want to prove that the new one, which means the XYZO, is a new orthocentric system. So basically we want to prove that O is a orthocenter of the triangle XYZ. Now just think about this. We know that BH is a line BE, right? Which means that BH is perpendicular to XY, and also BH is perpendicular to AC. That means XY is in parallel with AC. And also because CF is perpendicular to XZ and CF is perpendicular to AB. So we know that XZ is in parallel with AB. Similarly, if we connect YZ, we know that I think I didn't draw it correctly, right? You know that the YZ has to passing through the Q point. Something, yeah, you know, I didn't draw it correctly. But we know that YZ also in parallel with BC. So we know that triangle XYZ is similar to triangle ABC. And now, because OX is perpendicular to BC, and we know that YZ is in parallel with BC, so OX is perpendicular to YZ. Similarly, OY is perpendicular to XZ and OZ is perpendicular to XY, which means O is a orthocenter of the triangle XYZ. Right? So we know that O is orthocenter of triangle XYZ. And then the question is, we want to prove that the new orthocentric system is symmetrical to the old orthocentric system respect to the 9-point circle center. We know that the 9-point circle center is a midpoint of OH. Right? It's a midpoint of OH. So we already proved that O and H is symmetrical to V. How about other points? We just need to prove that X is symmetrical to A as well, right? And we know that OM, this point is M, right? We know that OM equals to half of AH. And we know that OM is perpendicular to BC and BC also perpendicular to AH, which means that OX equals to twice of OM equals to AH, right? That means X and A are symmetrical to V. Right, and based on this, we can prove that B and Z are symmetrical to V, C and B and Z are symmetrical to V, C and Y are symmetrical to V. Okay, that's the second property. The third one. The orthocentric system of a triangle and the orthocentric system of its circumcenters share the same 9-point circles. So if you look at this figure, the orthocentric system of a triangle, that's ABCH, and the orthocentric system of its circumcenters, which means that's X, Y, Z, O, share the same 9-point circle, which means that we want to prove the because the 9-point circle, the radius, they are sharing the same 9-point circle. We already know that O is the circumcenter of the triangle ABC, and O is the orthocenter of triangle XYZ, and H is the orthocenter of triangle ABC, which means we just need to prove that H is the circumcenter of the triangle XYZ. Right? I hope you got that. We already proved that O is the circumcenter of the triangle ABC, and O is the orthocenter of the triangle XYZ. And we know that H is the orthocenter of the triangle ABC. So to prove this one, that's the circumcircle, that's the two orthocentric systems sharing the same 9-point circle, we just need to prove that H is a circumcenter of the triangle XYZ. And of course, we need to prove something else, but let's just think about this one. Because once we prove that H is a circumcenter of the triangle XYZ, now we know that for the two systems, they have their 9-point circle are all on this point V, right? So to prove that 9-point circle are the same, we need to prove that the centers for two systems are the same point. Right, that's the first step, and then we consider about radius. So if you look at the point H, because we want to prove that H is a circumcenter of the triangle XYZ, that means we just need to prove that HX equals to HZ, right? And what is HX? HX is a radius of the circumcircle of the triangle BHC, right? And if you remember that we had the property on the orthocenter, so let's see, we have a triangle here, and we draw the circumcircles of this triangle. We find the orthocenter. And if we extend it to this point, let's call it D prime, then we proved that HD equals to DD prime, right? This distance equals to this distance. And we also proved that triangle BHC is congruent to triangle BD prime C. Right, we proved that, which means the radius of the circumcircle of triangle BHC equals to the radius of the circumcircle of triangle BD prime C. Similarly, the radius of the triangle AHC equals to the radius of the circumcircle of triangle AEC. And we know that triangle BD prime C, sorry, not EC, E prime, right? Triangle BD prime C and triangle AE prime C, they are all cyclic in the same circle, which means that the radius of the triangle AE prime C equals to the radius of the triangle, the radius of the circumcircle of the triangle BD prime C, right? Which means the radius, let's R triangle BHC equals to the radius of the triangle AHC equals to the radius of the circumcircle of the triangle AHB. Right? And now let's come back to this one. So, HX is the radius of the circumcircle of triangle BHC, and HZ is the radius of the circumcircle of triangle AHC. We know they are equal, so HX equals to HZ equals to HY. Means that H is the circumcenter of the triangle XYZ. Right? Then we know that for the 9-point circle in triangle XYZ and the 9-point circle of the triangle ABC, the center is the same. It's on the midpoint of segment OH. And we still want to prove that the radius of the 9-point circle are equal, which means that we have to prove the radius of the triangle ABC equals to the radius of the triangle XYZ, right? So let's do this. We know that the radius of the circumcircle of the triangle XYZ is HX, which is the radius of the circumcircle of the triangle BHC, which is the radius of the circumcircle of triangle ABC. So they're equal, which means that the radius of the circumcircle of triangle XYZ and radius of the circumcircle of triangle ABC are equal, and the center, the auxiliary center and the circumcenter are swapped for two triangles, which means that the 9-point circle are the same point and the radius is the same. So they're sharing the same 9-point circle. That's property 3. Let's see property 4. Property 4. The centroids of the 4 triangles formed by the points of an orthocentric system constitutes a new orthocentric system. These two systems are homothetic with respect to the 9-point circle. Okay, this is an interesting problem. I'll say property. This property actually is one way to prove the Euler line. Let's look at this one. Let me make it. this has to be a larger one. Yeah. So we have the first orthocentric system, and we want to find the centroids of the four triangles, right? Centroids of the four triangles, that's a triangle ABC, triangle ABH, triangle BCH, and a triangle ACH. So let's find the midpoint first. And the midpoint here, midpoint here, midpoint here, midpoint here. Right, yeah, roughly say it looks correct. Midpoint here. So P S T R. Okay. Now we want to find the centroids of triangle ABH. So we connect AS. Right, we connect AS, and we connect BR or HP. So that's a point, let's call it X. So X is the centroid of the triangle ABH. And now let's find the centroid of triangle BHC. Let's call it Y. And now let's find the centroid of triangle ACH. Let's call it Z. So basically we want to prove that, and also we need to find the centroid of the triangle ABC. Right. So this point, let's call it G. Basically, we want to prove that X, Y, Z G. We want to prove X, Y, Z, G form a new orthocentric system. Right. Okay, think about what is X. X is a centroid of triangle ABH. Y is a centroid of triangle, Y is here. That's the centroid of the triangle BHC. And Z is a centroid of triangle AHC. Right? And G is a centroid of triangle ABC. Okay, now we want to prove that, basically we want to prove YG is perpendicular to XZ. Right, if YG is perpendicular to XZ, then we know XG is perpendicular to YZ and ZG is perpendicular to XY, so G is also center of the triangle XYZ, then XYZG form an orthocentric system. The question is, how can we prove that YG is perpendicular to XZ? Okay. The first thing we can look at is AX to AS, right? AX to AS, that's 2, 2, 3. That's a property of the centroid, right? So we know that AX to AS equals 2, 2, 3, and we know that AZ to AT equals 2, 2, 2, 3, right? Z is a centroid of triangle AHC, so AZ to AT equals 2, 2, 2, 3. And we know that if we connect ST, just imagine, if we connect ST, because S is a midpoint of BH, T is a midpoint of CH. If we connect ST, then we know that ST is in parallel with BC, right? Which means, so we know that AX to AS equals to AZ to AT. And that means XZ is in parallel with ST. So based on these two, we got XZ is in parallel with BC. XZ is in parallel with BC. Right. Now let's think about this one. So we find the circumcenter of the triangle ABC, okay? We just do the perpendicular bisector of BC, and we do the perpendicular bisector of AC. So on this point, let's call it O. Okay, let me just rewrite Y as here, so it's easier to read. Right, okay. Now think about HY2 because Y is a centroid of the triangle BHC, so HY to HM equals 2, 2 to 3. Or say HY to YM equals 2, 2 to 1. Right? HY to 1M, that's 2 to 1. And also, if you look at AG to GM, AG to GM equals 2, 2 to 1. So we know that GM to GA equals to GY, no, MG to MA equals to MY to MH equals to 1, 2, 3, right? MG to MA equals to MY to MH equals to 1, 2, 3, which means YG is perpendicular to AH. Sorry, YG is in parallel with AH, right? Because MY to MH equals to MG to MA. So we know that YG is in parallel to AH, okay? And we already know that AH is AD is perpendicular to BC, which means that AH or AD is perpendicular to XZ. And we know that YG is in parallel with AH, which means YG is perpendicular to XZ. Because YG is perpendicular to XZ, so we know that XG is perpendicular to YZ and GZ is perpendicular to XY, which means G is also center of the triangle XYZ. Okay. And that's our first step, right? We just prove that the centroids, the four centroids, form a new orthocentric system. That's X, Y, Z, G. And we still need to prove that the new system is homothetic to the old system at A, B, C, H. That's an interesting part. Let's look at it this way. So we want to prove the homocentrics, then we need to find the homocentric center. Homocentric center would be the V, right? So let me think. We want to actually prove this. Okay, we want to prove that O, G, V, of course, V is on OH, right? We want to prove that O, G, H are collinear. So we know that OM equals to I think I'm not drawing this in a good way. So let me just review it. For example, here it's easier to review. So think about that we have the circumcircle here for triangle ABC. And we have the circumcenter here, and we have the orthocenter here, H, right? This is O. This is OM. So if we do this, we can see, for example, let's call this point as P. We know that OM equals to half of PC. And because PC, HA is a parallelogram, so we know that PC equals to AH, which means OM equals to half of AH, right? I proved this many times, so I just listed it here. So we can look at this one and directly write it as OM equals to half of AH. And also we know that OM is in parallel with AH, right? And what about the YG? We already know that MY to MH equals to MG to MA equals to 1, 2, 3, which means YG to AH equals to 1, 2, 3, which means YG is 1/3 of AH. Right? YG is 1/3 of AH. Now, if we look at YG to OM, it equals to 1/3 of AH to half of AH, which equals to 2/3. Right? That's YG to OM. YG to OM. And YG to OM equals to HY to HM. Which means HGO are collinear. Right. If I just extract this part, you can think as this way. Y, M, O, G, H. Right, we calculate for the YG to OM. And then we found that YG to OM equals to HY to HM. And we already know that YG is in parallel with OM, which means HGO are collinear. And based on this, it's very straightforward to find the 9-point circle V here. And then we know that G is also center of the triangle XYZ, and H is also center of the triangle ABC, and we know that HG, the center, homothetic center is on the reference point connection, right? So if we connect H and G, we know that homothetic center is on A. And we also know that homothetic center would be has the same ratio as the ratio of the two figures. So the XZ to BC equals to XZ to ST times ST to BC, which is 2 to 3 times 1 to 2, which is 1/3, right? And we already know that HV, let me write it here. HV is half of HO, right? HV is half of HO, and GO, because MY to MH equals to 1 to 3, so that make OG to OH is 1 to 3, right? Which means GH equals to 2/3 of HO. And we know that HV is half of HO. So we know that GV is 1/6 of HO, which means GV to HV ratio equals to 1 to 3. And this one equals to the ratio of XZ to BC. So we know that V is a homothetic center of the two systems. Okay, that's property 4. Let's see property 5. The distances from the orthocenter of the triangle formed by the 3 chords cutting by the 9-point circle on the 3 sides to the vertices are respectively equal to the 3 chords cutting by the 9-point circle on the 3 altitudes. Looks like a very long sentence, right? So we have the triangle. Let's draw the. Yeah, this also need a large figure to look at. Right, we have the triangle ABC here. The question is that the distances from the orthocenter of the triangle formed by the 3 chords cutting by the 9-point circle on the 3 sides, right? So we first find the 9-point circle of the triangle ABC. And we know the circumcircle of the triangle DEF is a 9-point circle, but to make it easier to draw, let's find the midpoint, right? The midpoint should be here, and this midpoint should be here. This midpoint should be here, and also the midpoint of the segment. So wait, here? No, we're looking for the midpoint, right? So we have the, I think this is correct. The midpoint is here. And for this one, the midpoint should be here. Okay, so let's say midpoint M. And for this one, the midpoint is here. Okay, yeah, that's roughly correct. Okay, M, N, P. Okay, M, N, P, and S, T, R. Right, so the nine-point circle look like this. Right, this is R. Okay, it's a difficult figure. And we want to find the segments cutting by the 9-point circle on the 3 sides. That is MD, NE, and FP. Right, and we want to find the triangles that are formed by these 3 sides: PF, NE, and MD. And then we find the orthocenter of this triangle, and then we find the distance from the orthocenter of this triangle to the vertices. We want to prove that this distance is respectively equal to the 3 chords that are cutting by the 9-point circle on the 3 altitudes, which is here we have RD, SE, and FT. Right? The first thing is that we want to find the triangle that formed by MD, NE, and FP. So this can be done by this way. Let's just think about connect DE, right? And think about we do a parallel line that passing through N. We find a line passing through N and in parallel with ED. And then we find another line that passing through P and in parallel with FD, right? Let's connect FD. And let's call this point as X. So we know that NX is in parallel with DE, and we know that PX is in parallel with Px is in parallel with Fd. Now the question is that, can we prove, wait, I think something wrong. No, we shouldn't do this. We should passing through F. Because here is ED, we should do PM here and then do this. Let me redraw the figure. I think we don't really need the circle, so let's make the triangle to be large. A, B, C here. D, E, F. Right. And we find the midpoint of AH. Find the midpoint of BC. Called M. The midpoint of AC. So, right, roughly say here. Midpoint of AB. This one is P. And P, that's a three midpoint. And we want to find the midpoint of CH. This one as, let's call it S. And CH, we find the midpoint. This is midpoint, this is midpoint, so it should be in parallel with this AH, S, T, and also this one, Q. Okay? So we know that D, M, T, N, S, E, F, P, Q, these 9 points are cyclic, right? Okay. Yeah, this is a much better figure. So now we want to prove that, first we want to find the triangle that formed by EN, DM, and FP. Right, we want to find these three triangles. If we do this, we need to do this. Yeah, right. So if we connect NM here, and we find the, we draw the in parallel line of MN that passing through point E. Draw a parallel line here. That should be like this. And then we find FD, and we draw another parallel line. We find FD, and we draw another parallel line of FD that passing through point P to here, and meet this point. Let's call it X. Okay, now the question is, can we prove that XD equals to PF and XM equals to EN? or C, can we prove that point X is on the 9-point circle, right? If it's true, then we find the triangle that formed by ENDMFP, which is XDM, right? So how can we do this? The first thing we can think of that this line is in parallel with this line, and this line is in parallel with this line. So EX is in parallel with MN, and also PX is in parallel with FD. I hope you are clear what I'm doing here. So basically, I connect MN and I find the lines that are passing through E in parallel with MN, and I connect FD and I find the lines that are in parallel with FD and passing through P, and we find these two lines meet on a point X. Now we want to prove that X is on the 9-point circle. So we know that PX is in parallel with FD, and we know that EX is in parallel with MN. To prove that X is on the 9-point circle, we just need to prove that this angle would be an angle that relates to like PDN or we want to prove that PXE equals to, for example, PDE or PME or PNE, right? Then we directly prove that PXE, because that PXE equals, for example, PNE, then we prove that PXNE are cyclic. Then we know X is on the 9-point circle. Now the question is, what is the angle PXE? Right, what is the angle PXE? This angle is actually formed by, because this line is in parallel with this line and this line is in parallel with this line, so we can just extend it a little bit. We find a point here, then we know that this angle equals to this angle. Call it point Y, right? We know that this angle equals to this one. And because, see, this angle equals to this one, because this one is in parallel with this one. So we know that this angle also equals to this one here, right? Of course, this one equals to this one. And let's think about how can we prove that PXE equals to angle, for example, PME or angle PNE. P is a midpoint, M is a midpoint. So let me think. Okay, so let's try. This angle, the angle YDM, this angle equals to angle BDF equals to this one, right? So the angle YDM equals to angle BDF. Also the angle YMD equals to angle NMC equals to this one. And what is angle BDF? The angle BDF equals to angle. So if we do this connection here, this angle equals to angle FDE So angle BDF equals to angle FEM. And angle NMC, this one equals to angle NMC, yeah, equals to angle, let's see. I want to do this connection. I don't know whether it's good or not. Let's just try. The angle NMC, this one. Oh, no, should be here. So should be this connection. Right, it equals to angle DEN. So basically we want to find 180 degree minus angle YDM minus angle YMD, which means we want to find 180 degree minus angle FEM and minus angle DEN. Minus angle FEM minus angle DEN. We know that the angle DEN equals to angle FEA, right? Angle DEN equals to angle FEA. See, because DEF are the foot of the altitude. So we, from the orthocenter property, we already know that angle DEB equals to angle FEB. So we know that angle DEN equals to angle FEA, which means 180 degree minus angle YDM minus angle YMD equals to angle Y equals to angle X, also equals to 180 degree minus angle F. The angle YDM is angle FEM. Also, angle YMD is angle FEA. So it equals to angle minus this one, so that's this angle, right? The angle MEC. So what we got here is that angle is that correct? FEM. FED or FEM? Hold on. Angle BDF, this angle equals to, right, FEM. Okay, yeah, that's correct. So the angle MEC. And what about angle MEC? We want to prove that angle X equals to angle Y equals to something like angle PME, right? Or angle PNE. What is angle PNE? Wait, angle PNE actually, because P is a midpoint of AB, N is a midpoint of AC, so angle PNE is actually angle C, right? So we just need to prove that angle MEC equals to angle C, right? And E is a foot of the, that's easy to do. Okay, great. Let's see. Because the triangle BME is a right triangle, right? Sorry, not BME, BEC. Triangle BEC is a right triangle. And M is a midpoint, so we know that ME equals to MC, which means angle MEC equals to angle MCE, right? And angle MCE equals to angle PNE. And angle, so now we know that the angle MEC equals to angle X, right? This one equals to angle X. And also MEC equals to angle PNE. So we know that angle PNE equals to X, which means angle PNE equals to angle PXE. So we know that X is on the 9-point circle. Okay, yeah, just because the figure is not as what I draw when I prepare for this problem, so it took me a little longer to derive this one. So let's review it again. Because we already know all of these parallel lines, so we know that angle X equals to angle Y, right? And what is angle Y? Angle Y is 180 degree minus angle YDM minus angle YMD. Then I derived the angle YDM, basically the angle YDM equals to angle BDF. And because the FDME are cyclic, so angle BDF equals to angle FEM, right? And because EDMN are cyclic, so angle NMC equals to angle DEC. And we know that E is a foot, D is a foot, so we know that angle DEC equals to angle FEA. Then we know that 180 degree minus angle FEA minus angle FEM is angle MEC. So we just need to prove that angle MEC equals to angle X, right? And because BEC is a right triangle, M is a midpoint, so we know that ME equals to MC, so angle MEC equals to angle C, and angle C equals to angle PNA, right? Angle PNA, which means that we know angle MEC equals to angle PNA equals to angle X. So basically we know that angle PNE equals to angle PXE. So X is on the 9-point circle. Okay, good. Now we just find the triangle that formed by the 3 chords cutting by the 9-point circle on the 3 sides, right? Which PF equals to XD and EN equals to XM and DM, that's a segment cutting by the 9-point circle on BC. So we find this triangle finally. Good. And the problem is that the orthocenter of this small triangle, right? The distance from the orthocenter of this triangle to the vertices equals to the distance that's cutting by the 9-point circle on the altitudes. So let's just try to find the let's see. Okay, we have this one. Right, that's a perpendicular line here from X to DM, right? We draw the perpendicular line, and from D to XM, or let's see, from M to XD, we draw another parallel line, perpendicular line. So this is the orthocenter of the triangle XDM. Let's call it K, okay? Let's call this point as K. Now we want to prove that KD, or let's say KX equals to something. Maybe I didn't draw it perfect. Yeah, I think I didn't draw it perfect. It should be like this. Anyway, so let's think about xk. We know that xk is perpendicular with dm, and also sd. See, sd is perpendicular with dm, which means we want to prove that xk equals to sd. We just need to prove that xkds is a parallelogram. To prove it's a parallelogram, we already know that xk is perpendicular to dm, and also sd is perpendicular to dm. So we know that xk is in parallel with sd. Then we just need to prove that sx is in parallel with kd, right? And we already know that kd is perpendicular to xm, which means we just need to prove that sx is perpendicular to xm. Right, we just need to prove sx is perpendicular to xm. Let me write it down so it's easier to follow. We know that xk is perpendicular to dm, and we know that sd is perpendicular to dm. So we know that xk is in parallel with sd, right? And we want to prove xkds is a parallelogram, so we just need to prove that xs is in parallel with kd. And we already know that kd is perpendicular with xm, right? Because k is also center, right? So kd is perpendicular to xm. Then we know that we just need to prove xs is perpendicular to xm, right? And if we connect sm, we know that angle sxm equals to angle sdm, right? Because angle sdm, sd is perpendicular to dm, so angle sdm equals to 90 degrees. Then we know that sxm is 90 degrees, which means sx is perpendicular to xm, which means sx is in parallel with kd. So sxkd is a parallelogram. Therefore, we know that kx equals to sd. In a similar way, we can prove that kd, well, actually, we already have it here, right? Kd equals to sx. We just need to prove kd also equals to another segment, this one, cut this one. Yeah, FTR QE. I mean, in the similar way, we can prove that, right? Okay, that's property 5. And see the property 6. Property 6. The chords cutting by the 9-point circle on the 3 sides of a triangle and the distance from the circumcenter to the 3 sides can be used to construct a cyclic quadrilateral. Okay, okay, let's draw a big figure here. A, B, C, D, E, F. So we want to find the 9-point circle, right? Find the midpoint. Midpoint should be this one. Okay. H R M N P S T Q. Right, that's a 9-point circle, and the problem is saying that the chords cut by the 9-point circle on the 3 sides of a triangle, and the distance from the circumcenter to the 3 sides can be used to construct a cyclic quadrilateral. Okay, now we want to find the circumcircle as well. So that's a circumcircle. Right. Okay. So this is a point O. And we want to find the okay, that's our 9-point circle. This is center V. Okay, we basically want to find the cyclic quadrilateral formed by the ENPFDM and OMONOP. Right. So think about that. We need to find our triangle first, right? Let's see. If we do this connection, draw it here, and we just proved that, right? So this would be our X point. We know that. Let me draw it here. We know that FD is in parallel with PX and X. The triangle XDM is our 3-chord triangle. So we know XDM, that's our 3-chord triangle. Then we know that our quadrilateral must include these triangle, right? And what about OM, ON, and OP? We need to find a way to move these 3 lines on the side. Right, we need to find a way to move the 3 lines. Let's see. The question is how can we form this quadrilateral? Let me think. Because we want to have it, the ON and OP and OM in a way, right? If we just do this, then we have it here. This one is here. Then we need to prove that another one equals to this one. And yeah, the idea is that we need to find the fourth point, right? Once we find the fourth point, and then we know how we draw the parallel lines, and we know how we eventually get it. Let me think. See, we have this one in parallel with this one. What if we draw another in parallel line of this one to here? Not sure if it's correct. Yeah, let's try. Right? So we have the ON here, and we want to use the ON, OM, OP. The question is, how can we relate this to the 9-point circle? We already know that ON equals to half of BH, right? ON equals to half of the BH, which equals to BS or SH. Then how can we form it? SH. This is 90 degree. So BS or SH equals to SF, right? And are we going to use this one here? No, I don't think that's correct. I have an idea. So look at here. Because ON, OM, and OP, we feel that OM may be the shortest, right? OM equals to half of AH. So, which equals to QF. Right? OM equals to half of AH, that's AQ or QH, also equals to QF, which means that we should connect FM here and make a parallel line of FM here, and let's call it Z. Let's try to see if Z is a point we're looking for. Then we connect SZ and XZ. Oh, XZ and DZ. Right? We know that Z is MZ equals to FQ equals to AQ equals to QH equals to OM. Now we're looking for the relation between XZ and OP, also the relation between DZ and ON. Right? ON equals to SF. So if DZ equals to SF, that means FZ equals 2. Fz is in parallel with SD. And we know that S is a midpoint of BH, but D is not a midpoint. So let's see. Wait a second. Let's redraw a figure. This is math. Let's try this problem again. So we have the triangle ABC here. Right, we find D, E, F here, right? And we want to find the midpoint. Let's call it H, the midpoint here, midpoint here, the midpoint, midpoint. And midpoint, right? That's roughly say our 9-point circle. Let's call it, let's call it M. This one is N. P, S, R, T, right? Let's draw the 9-point circle. Okay, and we want to find the circumcenter, which is O here, right? And let's think about how to, we can do the different ways, right? So if we find NP here, we draw the parallel line here, and we know that this is X and M connected. Wait, did I draw the wrong line? Yeah, so let's try. Connect to P here. No, N connected to, wait, no. Yeah, N connected to D here, right? And then F in parallel line would be here, and also But that case would be this one. For property 6, it's difficult. Let's redraw this figure. It's a mess. A, B, C, D, E, F, H. So we have the midpoint here and midpoint here. This is a midpoint, and this is a midpoint. This is a midpoint. And also we want, because this is a midpoint, we probably with this one. So this is a midpoint, right? N, S, actually, let's call it L. N, L, and we want to find the another midpoint here, P, Q, R, right? And let's draw the circle. Wow. Okay. Now let's consider about this figure. Previously we got this by, we have the, right, O is here. And previously we got the triangle. Basically that's our EM and NF and DL, right? Remember? So now we want to find the triangle again. We can connect the NL and make a parallel line of the NL, right? And we also can connect because N is a midpoint M, D. Wait, why this time the line is on this side? MD and here. Then that connection is wrong, right? So if we connect ED, yeah, we should connect ED, right? Not MD, ED, and do the parallel line of the ED. That's our triangle DSL is our chord triangle, right? That's what we got from property 5. And now we want to find OM, ON, OL to be on, to form another quadrilateral. And here the shortest will be OM, right? And we know that OM equals to half of BH. So it equals to BQ equals to QH equals to FQ, right? OM equals to FQ. And also what we have about ON equals to half of CH, right? ON equals to half of CH, which is equals to CR equals to RH equals to RD equals to RD. That's ON equals to RD. Interesting. Is R the point we're looking for? I don't know. And OL equals to half of AH equals to OL equals to half of AH equals to AP equals to PH equals to PF, right? So let's connect PF. If R is a point we're looking for, we just need to prove that PF equals to we just need to prove that PF equals to LR. Oh, actually, SR. Right? Let's try. So let's connect DR, SR, and LR. We already know that DR is DR equals to RH equals to RC equals to DR equals to RH equals to RC equals to NO, right? So this line is done. And what about RS? RS is longer than RL, right? So we want to prove that RL equals to OM. Interesting. If RL equals to OM, we know that OM is perpendicular to this line, right? To AC. Is RL perpendicular to AC as well? I don't know. What is RL? Actually, how did we get the R? R is the midpoint of HC, right? And what about RS? Actually, the question is why the PR is perpendicular to these lines, right? To the NL. Oh, which is obvious because P is the midpoint of AH, R is the midpoint of HC, so PR is in parallel with AC. And we know that N is the midpoint of AB, L is the midpoint of BC, so NL is in parallel with AC, which means that PR is in parallel with NL, right? So we know that PR is in parallel with NL, and we already know that NL is in parallel with FS, so we know that FS is in parallel with NL and in parallel with PR and in parallel with AC. Okay, now what we can get here. NL is in parallel with PR, which means NP equals to LR. Wait. Something wrong. See, P is a midpoint of AH, R is a midpoint of CH, so PR is in parallel with AC. There's no problem. And yeah, triangle AFH is a right triangle, right? Let me think. So RS equals to FP, right? Because wait, RS equals to FP, and FP equals to half of BH, which equals to, oh, okay, it's here. RS equals to FP equals to half of BH. Half of BH equals to OM. Right, so RS equals to OM. And RL would be equals to OL. Let's try. RL equals to NP. Wait, no. RL. Hold on. See, I feel I made some mistake here. No, this is wrong, right? Because F is not the midpoint, N is the midpoint. So we know that PR is in parallel with AC, that's no problem. And PR is in parallel with NL. FS is in parallel with PR, in parallel with NL, in parallel with AC. So we know that PF equals to RS, no problem of it. PF equals to RS, which means PF equals to RS equals to half of AH equals to OL. Right, now we want to prove that RL equals to OM. So RL equals to NP. Right, and NP equals to half of BH equals to OM. Oh, it's here. Now we just prove it. Right. Okay, let me explain this a little bit more. So we have the DSL, triangle DSL, and we just need to find another point, which is a little difficult to find, but if we look at the figure, we know that, we already know that DR equals to RH equals to RC, and we know that ON equals to half of HC, which means that ON naturally equals to DR. Then we are thinking whether R is a point we're looking for. To prove that, we just need to prove that RS and RL equals to OM and OL respectively. So because PR is in parallel with AC, so and also FS in parallel with AC, so we know that the RS equals to PF. And notice that N is a midpoint, F is not, right? So PF equals to half of AH, which equals to OL, which means that RS equals to OL. And for RL, because RL equals to PN, and PN equals to half of BH equals to OM. So RL equals to OM. Then we just prove that RLSD is a quadrilateral we were looking for, and we know that RLSD are cyclic. So we just prove that these lines can form a cyclic quadrilateral. Whew. Okay, great. So this is our first video about the 9-point circle supplementary of the properties. We will have more about the 9-point circle. It's a very interesting figure. Okay, I hope you like this video. Thank you. Let's catch up. See you in next one.